Hello there. So 63 of 150. Time to go. K's smallest element in BST. So let's take a look at that problem. So 63rd problem. We're looking at it in order traversal to get the in order and get the K smallest element. So basically, every item we visit in order, then we just decrement, and until we get to 0, then we found our item. Remember, we're going to, let's say K is always going to be less than N, so that means it's always going to be inside the tree. So pretty great. Okay, so let's do some in order traversal. Let's do it in recursive, and then do it in stack, so we get a better idea about like how the recursion works. It's also always good to get some more practice in, so it's always good. So let's say self.k. This is pretty cool. I just learned you can I say create items inside your class by just using the function, calling the function. It will create items in your stack, which is pretty, in your class, which is pretty crazy. And return self.result. Okay, so how does this work? So we're gonna create a helper, and helper is basically gonna go left. It's gonna do some work in between, like see if we hit 0, subtract the k, and if we hit 0, let's return the value, and otherwise let's move right. So if root self.helper root.left. So that basically, when we're not doing a helper, that means we're not doing any work. So we're not decreasing or increasing anything. We're not just doing anything at all. So minus equals 1 if self.k is equal to 0. Then basically what happens here is self.result is equal to root.val and return, and that means we're done with this particular option, and we want to do the self helper root.right. And with that, we insert all the items in the left, we pop an item, right? So basically we pop out, we have our current root value, and with that we minus 1, that's our smallest item, and we check if that's the value that we want. If we want the first value, then yeah, it becomes 0, and then we return it. If it's not, then we keep going, and we check the item for its right side, see if there's any right item. It's always going to be bigger, so if there is, that means we're going to check that item. It's going to be, and we're going to keep going left on that node until we get to the smallest node, next smallest node. Or if it's the only node, then we just go and there's nothing to the left, and we just run that node and we do a subtraction and so on and so forth. I think we'll get a much clearer picture once we do this stack, and we can also, if you want to get more practice in, you can do it by hand, and that way it becomes even more clear. But here we go. We're currently running at 33%, 86% memory usage. All right. I think that's done with this code here. Alright, so let's do the iterative method. So first we use a stack equals a empty stack. And what we're going to do is the same thing. Basically keep appending items to the stack once, and go left. Go all the way down to the left, go all the way to the end. So root equals root.left. So then we're going to do a node equals stack.pop. That means we found our smallest node, and we're going to minus equals 1 if k equals 0. We're going to return node.val. Otherwise, root equals node.right. Once we're done, that means once we're done with that particular operation, we're going to check the right node, and it's the same thing. We're going to go in, see if that's the smallest node. If it's not a node, we continue popping. If it is a node, we go in, we take a look, and see if there's anything to the left, append those, and then start popping those nodes. If it's not anything, then we just pop, then we append that only node, the right node, and we pop, and then so on and so forth. Same deal. And run. And submit. So this should be a little bit faster. Anyways, but then the memory usage is quite heavy. I guess the thing is that the memory management from Python is in recursion might be better than our memory management. I don't know. I'm not sure. I mean, there's only 0.1 megabytes difference. Anyways, the point is, we learn how to do an in-order traversal of a binary search tree, whether we need to do it recursively, and doing the items that way, or using it iteratively and using a stack by using a while loop to do all the left nodes, and then doing our operations, and then doing our right node, and then repeating that process of always going down to the least smallest amount of left, and then checking the right, and then going back up that stack and checking every right node of that item. And that's how we do in-order traversal. Very good problem. I think is a good exercise to get ourselves to visualize what's going on in a in-order traversal, and it's a great exercise. Well, thank you very much for watching. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.